Let's go to LeetCode 264, ugly number 2. For this question, let's return the nth largest ugly number. For ugly number, that is those number which is coming from the factor 2, 3, or 5. So let's look at the example. The first is 1, right? Second, 2, 3, and this is 2 multiplied by 2. This is 5. This is 2 multiplied by 3. This is 2 multiplied by 2 by 2. This is 3 multiplied by 3. This is 2 multiplied by 5. And this is 2 multiplied by 2 multiplied by 3. So um, intuitively, what we think about is that we use our priority queue and put 1 into it. And every time we pull out the minimum one, and we push into the priority queue 3 numbers, this number multiply 2 and multiply 3 and multiply 5. So in that case, it will have a 3n number, the worst case on the priority queue, right? So the time complexity will be O n log n because the priority queue that has a log operation, and space here will be O n. But we can do better, right? So the concept for us is that, for example, this array, right? So initially we have one, 2 pointer. This is 1, 2 pointer, and 3 pointer, and 5 pointer, all pointing to this number. Let's use different color for for 2 pointer, for 3 pointer, and use this one, and they are all pointing to here, right? So for this is so what does this one mean? This means the number which can multiply by 2, or the number which can multiply by 3, or the number which can multiply by 5, right? So the next candidate will be this number multiplied by 2, or multiplied by, or the number which can multiply by 3, multiply by 3, or the number which can multiply by 5, multiply by 5, right? So for this case, we have the candidate 2 and 3 and 5, right? So from these 3 numbers, we find the smallest is 2. So we are put this 2 in our array, right? And our 2 pointer, we can move 1. That is um that is the next candidate for our multiply 2 can coming from this number, right? So so the case is, so this will be removed, right? And so let's look at the next round. What will happen? The next round, because the 3 pointer and the 5 pointer, they didn't move, right? So the next candidate for the green and the blue one is still 3 and 5, but for the 2 pointer, right? Because it moved, so we are going to have another candidate that will be 2 multiplied by 2, that will be 4, right? So now what we do is that we compare these 3, find 3 is the smallest. So what we do is that we're going to put this 3 in our next array, right? And we are going to use, so we'll say this is our current number, right? Use I. This is 3. So 3 will be put into our array, right? And in this case, what happened to our 3 pointer, right? Our 3 pointer will also move 1 index, right? Because 1 multiplied by 3 we already calculate, right? But 2 multiplied by 3 we didn't calculate. So that we can move 1, for 3 pointer, we can move 1, right? So this will be the next case. And after this, what will be the next candidate? We'll see the pointer is at 1, right? So next candidate for 5. And 2 pointer, I didn't move in this round. It's still 4. And what about the 3 pointer? 3 pointer is here, right? It's 2. So next candidate for this kind multiply, which can multiply 3 is this 2 multiply 3, right? So we are going to have 2 multiplied by 3, that will be 6, right? So our next candidate will be 5, 4, 6. So among this, we'll see 2 is the smallest, right? We'll see the 4 is still the smallest. So our next number will be 4, right? And because we put a number for 4, right? So we'll see the number which calculate from multiple by 2, that is 2. That has been used. That means for our 2 pointer, it's able to move one index, right? So we can have 2 pointer move to here, right? Because the next one is previously is 2 multiplied by 2. Now it's 3 multiplied by 2. And what's the next? So we'll see the next candidate for 5 hasn't changed, right? And for 2 hasn't changed. And 3, for 2 moved to 3, right? 3 pointer is still pointing to 2 right now. It hasn't changed, right? So next case, 5, 5, 4, 6, right? And for this for this 4, right? We moved here. That is so next case for this red part, right? The 2 pointer to become, we should remove this, become 6. 6, right? Because this one 3 multiplied by 2 will be 6, and 2 multiplied by 3 will become 6, and the 5 pointer will be still pointing to 1, right? So next the smallest one is what? Is 5. So we'll put 5 here, right? So in this case, 5 multiplied by 1 is already calculated. So for 5 pointer, we can move 1, right? Because 5 multiplied by 1 is calculated, but 5 multiplied by 2 is not calculated. So let's look at the next round, right? So every time we put 1, of course, our index is changed, right? Change to this. And what's the next round? Next round. So the next round, we're going to get rid of this, right? Because the 5 pointer already been changed. So that means our next candidate for the coming which can multiply by 5 will be coming from these 2, right? So that will coming from 6, right? So that will come goes to 10. To multiply by 2, that will be 10. So now the next candidate, there are 6, 6 and 10, right? This 6 is coming from 2 multiplied by 3, right? Come here. And this 6 is coming 3 multiplied by 2, right? So 3 pointer multiplied is still pointing to the number 2. So we'll see among this, 6 is the smallest, right? So we can put 6 or this kind of 6 here, right? So that means that because we don't allow duplicates for this number, in this case, both 2 pointer and the 3 pointer, they need to move, right? So 3 pointer is moved to here, and 2 pointer is going to move to here, right? So the pointer is going to pointing to the number which can multiple by 2 or multiple by 3 and multiple by 5, which can be our, which is the smallest will be our candidates. So the pointing is pointing to the number which can multiply by this uh, 2 or or 3 or 5, right? So doing like these approaches, we just fill our ugly array. And in the end, we return the n minus 1 ugly array. So let's implement the code based on this approach. So we're going to have um, I'm going to have int ugly equals new int n, right? So let's say ugly 0 will be 1, right? So we're going to have 3 pointers, L2 equals 0, L3 equals 0, L4, L5 equals 0, right? That means this pointer is the last calculated multiple by 2 or 5 or 3 positions, right? So what we are going to do is for int I equals 1, I smaller than n, I plus plus. So we are going to have our next candidate, the V2 will be ugly L2 multiplied by 2, right? And V3, the next candidate is ugly L3 multiplied by 3. And V5, next candidate, which is coming from multiplied by 5, right, will be ugly L5 multiplied by 5, right? So we'll see ugly I will be max.min, V2 max.min, V3, and the V5, right? So the things that we are trying to see, if ugly I equals to, right, equals V2, that is coming from multiple by 2, right? In that case, just the 2 pointer need to move, right? So that is our L2 should increase by 1, right? Here we are write we cannot write else. We are write still use if, right? Remember the number 6, right? The number 6, it can coming from the 2 pointer multiplied by 3, right? And also 2 pointer at 3, right? 2 pointer also coming from the 3 pointer multiplied by 2, right? So in that case, the 2 pointer need to move to the 4 for the next one, and also the 3 pointer need to move to the 3 for the next can multiply by 3 candidates, right? So when we cannot write else, we still use if, because if this number equals V1, V2, 2 pointer need to change, increase. If equals V3, 3 pointer need to move. We cannot miss, right? So we'll have I equals V3, then L3 should increase by 1. And we'll write if ugly I equals V5, then 5 pointer should increase by 1. In the end, we just return ugly n minus 1, right? And also the Python code is very similar. Let's also write the Python code. So we are going to have ugly equals this one multiplied by n, right? So we know ugly 0 will be 1. And we're going to have this 2 pointer equals to 3 pointer equals 5 pointer, right? The point is at index 0 initially. Then what we do is for I in range 1 to n, right? So we're going to have V2 will be V2, V3, V5 will be ugly L2 multiplied by 2, right? Ugly L3 multiplied by 3 and ugly L5 multiplied by 5, right? So the thing is that ugly I is going to be mean V2, V3, V5. Okay. So that means that so we'll say if ugly I equals to V2, that means our 2 pointer we should increase by 1, right? And we'll say if ugly I equals V3, then our 3 pointer need to increase by 1. And also we write if ugly I equals V5, in this case 5 pointer should increase by 1, right? So in the end, we just return ugly n minus 1.